Hi guys, this is Shah and welcome back again to another new video from my channel. So in this video also we will discuss a sheer short questions for chemical science. This is from the previous year's question of GATE exam, which was based on Chaykovsky reactions. So let's get started. This was the questions. Now if you have not seen till now my previous video on Chaykovsky reaction, which describes the basic mechanism of the Chaykovsky and the solved problem from CSIR and Gate, which is very much important for understanding the concepts, just check it out. So you have known that for Chaykovsky you need a sulfur ylide compound. What is sulfur ylide? Just a two opposite charge will hold in the same compound, which is in stabilization. That is sulfur ylide. So as you have seen here, sulfur ylide is one of the reagent for this questions. So this is the negative charge, it will act as a good nucleophile, and this is the positive charge, so this whole term will act as a good leaving group, and this is the nucleophile. So now another reagent for, as we know, for Chaykovsky reaction is needed for alpha beta unsaturated carbonyl compound. This is the alpha and this is the beta unsaturated carbonyl compound. Now these two form the Chaykovsky, that's fine. So why this is needed? So there are some trick that why this is needed. That's the trick of the questions. Now we can understand you have a amine group and you have a carbonyl that may can form imine formations, and then may something happen by Chaykovsky mechanism. But what is the order? As they have set the order, first the amine and then Chaykovsky reagent, we will also go like this order. So first will imine formation happen with the compound amine, substituted amine they have posted, and the alpha beta unsaturated carbonyl compound. So imine formation will create this type of compound where nitrogen will be positively charged, and this one. Now you have no other options to go into the mechanism of the Chaykovsky because no other reagent is there. So only option is the attack of the sulfur ylide nucleophile. Now as we have said in the previous that conceptual video, that nucleophile will attack 1,4 addition. In sulfur ylide will make 1,4 addition in term of TCP, thermodynamically controlled product, when the sulfur ylide is much more stable and the condition are Hertz condition. So as you have seen here, that this negative charge is actually very much stable because of the stabilization of this, because of the conjugation with this carbonyl group. So this is a stable ylide. So if this is a stable ylide, obviously this will form 1,4 addition compound. Now 1,4 addition means 1, 2, 3, 4. This will form this type of compound. Now from that previous video we can understand the second step of the Chaykovsky mechanism is actually a negative charge of the carbon atom will attack somewhere to leave out the dimethyl sulfide leaving group to form a cyclopropane ring. That actually will happen here. This nitrogen lone pair will attack here, and this double bond will create a negative charge here, and this negative charge will attack this carbon center, so that to leave out the dimethyl sulfide, so to form this type of compound, means cyclopropane ring. For the time being you just consider the stereochemistry like this. I will discuss in the later part. Now you have water in the medium. Now in aqueous media, obviously this imine bond will not be stable because you know acidic conditions, imine bond is not stable. All the imine bond go to the reverse directions in acidic conditions. So you have as some extent of acidic conditions in aqueous medium, it will break. It will just go to the reverse directions of these imine formations. So this is the retroimine, okay, retroimine. So that will form what? The amine of the previous what we have started, and then the CHO means carbonyl compound. This is so like this. H2O when will attack, it will create HO, and this is H and this is nitrogen. So it will come back here, this will leave out. So this will form the carbonyl compound and the amine compound. So this amine compound we started from. That's why they have added catalytic amount, because it will regenerate in the last step of the reactions. Now to come back, what is the stereochemistry of the substituent? Now, as you can understand, you have a CH3 group and these two are the substituent. Obviously this they will retain in such a position that CH3 will not interfere with these two substituent. Now to get an intricate details concept, we have to go to orbital overlap concept, which is shown here. So what is saying here, you are look at this step. This is the attacking step and cyclopropane ring formation step. So this is the lone pair is coming here, and this double bond is making a negative charge here. So this is the electron efficient carbon atom which has an electron efficient lobe like this. So this is the electron efficient lobe. This lone pair or electron efficient lobe will make an orbital overlap of this carbon sulfur sigma star so that it can leave out this carbon sulfur. What the mechanism you can understand, I think. The Ca sigma star means sigma star increase in electron in the sigma star will make less bond strength of this Cs bond. That's why it will break out in the next step. So for all this type of reactions, it will form like this. This lone pair will attack here and attack Ca sigma star, and carbon heteroatom sigma star obviously will be more energetic because that are not stable. So it will form, that's why it will form the compound like this. Now in this intermediate, CH3 will retain such a position that it will not come in the steric interactions of these two bulkier group. These are two bulkier group. That's why they try to attenuate the CH3 group in the intermediate will try to attenuate the steric interactions from these two bulky group. That's why CH3 will be above the plane if these two are the below the plane, or vice versa. That's why the product like this, and CH3 in above the plane and these two are below the plane, and these two are far. That's why they are not steric interaction, making steric interaction between themselves. That's all for the reactions. Thank you for watching.